Hello, friends! Welcome to Coding Garden with CJ. Welcome to Code Wars Code Katas episode 35B. We're gonna have a good time. And as you can see, I now have a persistent leaderboard, and Daniel Garden just got a 45. So that's great. Let's get into this. Cool. Oh wow, that really covers covers me up entirely. I need to fix that. There's no easy way to do that. Let me just do the intro. So if you're new to the show, go to github.com/codinggarden/code-katas. You can see all of the katas I've solved in the past, and all of the katas that I solved tonight will be there as well. I recently made some updates, so if you look at the README, it has a breakdown of which katas were solved in which episode, and that's fully up to date. And if you go to the link here, which is code-katas.now.sh, you can actually filter across all of the katas that I've solved before. Andrew, Andrew was in the Twitch chat when I was testing this thing earlier because I added the leaderboard. Okay, any suggestions? Where can I put this leaderboard so it's not in the way? I guess I could put it at the top of the screen, but I guess I could put it at the bottom left. I don't know. Let me know. Where should I put the leaderboard? And also we need to make it smaller. I could make it smaller. Above the chat in a smaller font. Like above the chat on the right up here? Yeah, so that's my plan, Valentine, is eventually there'll just be a bot command, and that's where you'll see the leaderboard. What's that about? NPM does not support Node 13? Whoa. Put it in a Twitch extension? That'd be ideal, right? Because that way it's not on my screen, but then the user can enable it if they want to. Okay, for now, here's what we're gonna do. We're gonna make the text smaller. Let's see what that does. Not that. Is it this one? Bottom left, make it smaller when no one new entered the leaderboard recently. Yeah, so it automatically disappears after 90 seconds already. Let's see, leaderboard, font size, 1 rem. Oh. Well, somebody has to score. Let's also do this when it first starts up. We won't hide it. We'll show it when it first starts up. That's not bad. Let me know if this is weird because it's like right where I am. But that's not bad because it'll go away after 90 seconds. And also while I'm coding, I'm gonna hide it. So, yeah. All right. That's good. Okay. I had so many technical difficulties. Like people in the chat were like, it's broke, but I fixed it. It had the wrong live chat ID. I got a lot to fix. Let's say hello to everyone. Hello, Dan. Welcome to the stream. Hello, Ran. Have I ever talked about memoization? I don't think I've ever talked about it in depth. I might have used it before, but yeah. Hello, Merchan. Yeah, and Mattia with the 99.58. Cool. And the other thing is this is a persistent leaderboard now. So it's in a database. We can, right now it's just all high scores, but what we can do is filter it by, at least what's displayed on the screen. You only see the high scores for that particular stream, but then I'll make a website where you can see high scores over all time. Yeah. Hello, Anaboth. Hello, ATD. Hello, Astonix. Hello, Miguel. Or Nico. Hello, Angel. Hello, Daniel Garden. Hello, Jakochi. Hello, Mukesh. Hello, Mattia. Hello, Anaboth. Hello, Joe Mama. Hello, Carolinda. Hello, Morning Sage. Hello, Sean. Yep, you made it. And we're having technical difficulties, so we're kind of just hanging out. Andrew, I have some screenshots for you. Thank you, ATD. Have a great night. We'll see you later. Hello, Get Some. Hello, Grax. Hello, Joundy. Hello, Mattia. Given to Meow. Thank you. Welcome to the stream. Hello, Valentine. Hello, Doc. Hello, Grax. Hello, Merchan. Jitter Ted says, ship it. Yeah. And hello, Jitter Ted. Welcome. Maybe a little opacity? I think it's okay. Honestly, I think it's okay. The game isn't Electron. This chat window is Electron. The game is just a browser source. Hello, Heck. Dan Levy says 0.8. Are we talking about opacity? This will just be the stream where I tweak the client the whole time and we don't actually write any Kata code. Let me see what the opacity is. Yeah, it's 0.5. 0.3? It's a little better, maybe. I don't know. I'm gonna keep it. Okay. Lambda hype. Yeah, so in the Discord, I was talking with Doc earlier, and he came up with like a challenge with like functional programming. I don't think I'm gonna do like it's a really cool challenge, and I want to do it. But what I think I'm gonna do is we are going to go to katas I have not trained on. We're gonna go to probably like a 5 or a 4 queue, and we're gonna see if we can choose functional programming. Yeah, functional programming. We're gonna try to solve some katas that use functional concepts tonight, so that'll be fun. Thanks for the follow, Mad Child. Get Some says, while working on a project for a company, is it okay to use different libraries and packages? Will there be any copyright or license issues? It depends. So with open source, there are a lot of different licenses. I think GitHub has a breakdown of open source licenses. There are certain licenses that are totally free. Yeah, here's this this article on choosing an open source license or learning about open source licenses. So things like if you see a package has the MIT license, or I think Apache 2.0, there's some other ones. Those are essentially, you can use them for commercial use. There are other licenses that say they can't be used for commercial use, and then there are other licenses which are known as like Copyleft that say if you use this, your whatever you code has to have that same license and must be open as well. So that's not good for enterprise or corporate type thingies. Wait, this article doesn't have a rundown. I think the GPL3. Is it GPL3? ChooseAlicense.com. Here we go. You can learn about licenses there. But there are certain licenses, yeah, it's totally good. And really, you would want your company's like legal team to review the licenses to make sure that you can use those things. But yeah, companies I've worked at, we use open source projects all the time. Use the drop game to vote for katas. How would that work? Do I put several different katas names at the bottom of the screen, and wherever the most land, that's the winner? How does that work? Thanks for the follow, Jim. Hello, Alka. I didn't solve the currying puzzle. Create a leaderboard across multiple channels? I would love to. Like, yeah, like people could embed it on their stream as well. That'd be awesome. Estelionix, you made it. Hello, Grex. Can I make a video about advanced vanilla JS front end? Not quite sure what you mean by that. Nice, Merit Channel with the tractor emoji. But I have done things with vanilla JS before. I don't know what it means to be advanced, but yeah. What's up, Cheddar? Hola, amigo. Hello, Trigos. Hello, Willy Lump Lump. Welcome. Merit Sean dropped a deuce. Come on. Bob says the only programming is functional programming. Don't at me. Can someone explain functional programming real quick? I absolutely will. Before we get into a problem, yeah, let's cover the basics of functional programming. Please explain copyleft. Basically, so copyright makes it so that one entity owns the thing, and in order to use that thing, you have to license it and give credit. Copyleft is the exact opposite. It makes it so that whatever you make has to be open and free, just like the thing that you're using. Let's look at copyleft on Wikipedia. Yeah, copyleft, distinguished from copyright, is the practice of offering people the right to freely distribute copies and modified versions of work with the stipulation that the same rights be preserved in derivative works created later. So derivative works would be anything that, like, if you modify that library, you have to release your modifications under the same copyleft license. Whereas, like, to juxtapose that, I don't even know if that's the right word, but to compare that, contrast that against like the MIT license, if something has the MIT license, you're free to take that source code and modify it, but then you don't have to release it. You could put it under a completely closed license if you wanted to. Hopefully that helps. Have different katas at the bottom, and the most landed on wins. Yeah, that might be fun. Can I finally do the battleship solver? I don't want to do anything too hard. So, I actually decided today that I'm gonna take a week vacation. Like, I asked at work, they said yes. So this is gonna be my last stream for about a week or so, and I kind of want to take it easy. And I'm not gonna stream for about a week or so, but yeah. Yeah. Majestic Guy says, found some cool plant growing animations. Not sure if you'd be interested in them for your drop game. Let's check them out. Why not? Let's check them out. I need a better way to open links from this chat thingy. Ooh, I've seen this one before. It's pretty slick. Yeah, we could potentially do that for the drop target. How's this work? Does it just pop up? Oh, yeah, man. Yeah, that's pretty sweet. I would definitely want it to be like a cartoon, though. That's slick. I might do something like that. Last stream. I'll be back. I'll be back next week. Cool. Hello, Oscar. Greetings from Mexico. Welcome. What topics do you recommend studying to improve in JavaScript? It's a great question. I should have like a list for when someone asks a question like this. It's also a very wide question, like improving in JavaScript. I mean, for one, solve problems with JavaScript. For two, if you're not familiar with all the latest ECMAScript features like ES 2015, I would study up on those. Like get comfortable with arrow functions, with template literals. Is anyone else seeing this new view on Google? I don't like it. Like I feel like I can't parse the results. Does anyone else see this? Am I being like A/B tested? Because like they put this weird what do you call that? I can't think straight. But yeah, they put that thing there, and it seems like there's less text that describes what the link actually is. I don't know. Let's go here for ES 2015. Learn ES 2015. Comprehensive guide to ES 2015. Yeah, so there's this Babel article. Let's see. Yeah, any article that talks about stuff like this, I would say get comfortable with these types of features. The other thing is get comfortable with the this keyword. So call, apply, and bind. These are all classic functions that we use to modify this in JavaScript. I feel like my search results are just so oft. Call, apply, and bind. A this refresher. Yeah, so learn about this, how to modify this. Also learning a bit more about functions and the fact that in JavaScript, you can do a lot of cool things with functions and pass them around and stuff like that. It's a very general answer. Hopefully that helps a little bit. Maybe you could tell me some things you're having problems with in JavaScript, and we can talk about that a bit more. Merchant says, you deserve it, CJ, and your vacation coincides with my midterm, so I say this is an absolute win. That's great. Yeah, so if I'm not streaming, you can get work done for sure. Oh, thanks, Majestic Guy. Yeah, the plant's pretty cool. I don't think it is. Majestic Guy says they're not seeing results like that. I don't like it. Like, I feel... Like, you tell me. Like, I don't know. JavaScript split string. I'm just seeing, like, what the results look like. Like, to me, it puts more focus on the title of the page, and there's, like, less content displayed below it. I don't like it. Yeah. Breadcrumbs, that's the word. Yeah, these things. They're showing these breadcrumbs. Yeah, I don't like it. Yeah, Morning Sage says it's messed up there. I'm being A/B tested. Man, I don't like it. Did I do this garden simulation in my 15-hour stream? Nope. So in the 15-hour stream, I tried to modify Instafluff's penguin drop. Because he made the original game, the penguin drop. And we sort of got it working, where both YouTube and Twitch could do the drops. But then on Monday, I made this one from scratch with vanilla JavaScript, and then I added all the garden theming off stream. So it's the little seed that drops. I added the plants growing, all that good stuff. We need to start writing some code. Yeah, I've thought about this too. Yeah, is there a way for the parachutes to actually hit each other? We could just do more collision detection. So yeah, if two things come like this, they'll like bounce off of each other. That would definitely create more randomness. Okay. Oh wait, is it for mobile? That thing? I don't know. I don't know. Let's find a kata. Maybe let's try to do two. We'll start off with the 5Q. Right now we have it filtered down to functional programming, and then we'll do a 4Q. The code, yep. So if you go to my GitHub / seedling drop, you can see it here. Actually, I haven't pushed the latest, but you can see most of it. Because today I just added the high score backend as well. Cool. Any tips on not procrastinating? Nope, I am the worst procrastinator. Remake the bubble screensaver from Windows? That would be fun. Okay, let's find a kata. I've been streaming for, I guess, 20 minutes, but still, we gotta write some code. All right, church booleans. In lambda calculus, the only primitives are lambdas. No numbers, no strings, and of course, no booleans. Everything is reduced to anonymous functions. Booleans are defined thusly. True is a function that takes in t, which returns a function which takes in f, which, when invoked, returns true. And false is a function which takes in t, which returns a function that takes in f, which returns a function that will return f. Whoa. Your task will be to implement basic operators on booleans using only lambdas and function application, not and or exclusive or, to help the function unchurch. Oh wait, to help, the function unchurch comes preloaded and returns the native boolean given a church boolean. Unchurch, you pass it the true function, this will return true. Should not use the following: numbers, strings, booleans, boolean operators, objects, arrays, regex, or new. This looks crazy. Yes, we're gonna pick a kata, and then we'll vote on a kata. But while we're voting, I'll give a rundown on the fundamentals of functional programming. This looks insane. Like, I can't even comprehend what it's asking for. So that would be fun to do. Heck, I'm gonna hard pass on that one. True chooses the first parameter, false chooses the second. Yeah. Yep. Okay, what about this one? Buying the farm, irrigation. You bought the farm. Well, actually, you just inherited the farm after your grandfather bought the farm, in darker and more figurative sense. The point is, you now have a farm. It's a really long description. I'll keep the tab open. I don't want to invest reading it unless I'm actually going to do it. All right, let's just do this. I'm not even gonna look at them. We're gonna take those and we're gonna vote on them. So the first one is church booleans. Yep, that looks super weird. Which functional 5Q should I do? Oh, we're gonna use this to vote. I don't want to use the drop game to vote. Because I'd have to modify the game too much to do that. Why didn't that work, Cheddar? That should have worked. Weird. And thanks for the sub, Miriam. Welcome to the show. Buying the farm. This next one is partition on. Write a function which partitions a list of items based on a given predicate. Okay. Fun with lists, trees edition. You are given a linked list, the head, which every element points to the root of an integer binary tree. Implement the method flatten, which returns a binary tree from the values of all the trees without duplicates, sorted by levels. Jeez. This is a 5Q? This seems insane. Fun with lists. Yeah, it could have been some weird character when you copy pasted. Yep. Lazy chain. Method chaining is a useful technique in JavaScript, allowing better composability and readability of functions. One problem with standard JavaScript chaining is that chain methods are immediately executed upon creation. Okay. All right. Yeah. I'm sure. Like, if it takes me a few hours, I'm only going to do one. So it's really up to the people voting. Like, do you want to see me do multiple? Or do you want to see me struggle for 3 hours? And this one, the ugly truth about reduce. This is the second part. You need to resolve the first part before doing this kata. What's the first part? It's in beta. With the emergence of ES5, JavaScript stepped in the direction of being more functional with the new methods. But reduce and reduce write methods do not behave in the same way in JavaScript than in other functional language like Haskell and Scala. Okay, well we'll do this one, not this one. Yep. Just a second. So, cool. Yeah, so if you do exclamation mark drop space and then do markdown formatting with an image URL, that will drop that image. Did I copy this one? The ugly truth about reduce. Okay, so remember, if you vote for a very hard one, then you're going to watch me struggle for 3 hours. If you vote for a moderately hard one, then maybe we could do more than one tonight. So think about that when you vote. Yep, go there to vote now. Nice reverse psychology. I don't know. Okay, so let's talk about the basics of functional programming. I might have a GitHub repo for this. Let me see. It would be fun to see an implementation of map filter reduce. I've thought about doing that before. Yeah. Though I don't think any of the problems I chose do that. Variety show. What did I talk about on the variety show? Yeah, I did talk about functional programming here. Let's see what I did. Cool. Yeah, let's just use this. All right. Which one is the easy one? I whatever seems the easiest to parse. Yeah, there's conceptually hard and implementation hard, for sure. Like the linked list trees one, which one is that? Is it fun with lists? Like, this is probably doable, but I don't know. This is like, I don't know. Okay. Let's talk about functional programming. These are the objectives. We're going to define and describe functional programming. We'll define and describe pure functions. We will write a pure function. We will define and describe referential transparency. Define and describe first-class functions. Define and describe higher-order functions. Use some of JavaScript's built-in higher-order functions. Define and describe immutability. And describe why functional programming is useful. And then we'll solve problems using functional programming concepts based on what you choose. Which one's lazy chain? I think that seems doable. Okay. All right, I'm gonna read this definition, but we're gonna have examples, and really it's more about like the concepts itself. Hello, Ets. Thanks for dropping by. Good luck with the exam. Here's my break timer. Can someone be my my hydration reminder? Like every 15 minutes, remind me to drink water. Carolinda said I issued a 6Q. I don't know what you're planning to do. I'm gonna do a 5 and a 4. So I'm gonna try to do things that are a little bit harder. If I'm being really pedantic, technically church numerals are the basis of all functional programming, but don't ask me to explain why. Cool. Hello, Giovanni, Rich, welcome. Yep, that's true. Various things. Lazy chain. Okay. Every 10 minutes would be good. Thank you, Heck. Hello, Aiden. Okay, functional programming is a programming paradigm in which we try to bind everything in pure mathematical functions style. It is a declarative type of programming style. Its main focus is on what to solve, in contrast to an imperative style where the main focus is how to solve. It uses expressions instead of statements. An expression is evaluated to produce a value, whereas a statement is executed to assign variables. Those functions have some special features discussed below. So some common functional programming languages are things like Haskell, Scala, Erlang, Lisp, and JavaScript is a functional programming language. It's weird because it also has object-oriented aspects to it, and you can actually write JavaScript without using any of the functional aspects. Which is one of the things I like about it. It's actually gotten me to think more functional. I never thought about functional programming before I started writing JavaScript. Okay, we're gonna talk about a pure function. This is one of the first things you learn about functional programming. Let me disable my dark style. So a pure function. So a pure function is a function that has the following properties. I think it's two properties. The first one is its return value is the same for the same argument. So a pure function is a function where when you pass in a value, you're always going to get the same result back if you pass that same value in. It will never be different. Basically, you pass it in, you know you're always going to get the same thing back. No variation with local static variables, non-local variables, mutable references. Basically, you put something in, you can be guaranteed that you're always going to be given the same thing back. That's a pure function. And the evaluation has no side effects, meaning it doesn't affect anything outside of that one function. It doesn't modify global variables. It doesn't make network requests, which have side effects. It's a small little contained thing, and you can think of it like a black box. You put an input, something happens, and you get some output. But given the same input, you're always going to be given the same output. So that's one of the first things you learn about functional programming is pure functions. Let's see like an example of that. FP concepts. So if we have this function called add, it takes in a and b and returns a plus b. Is this a pure function? Based on the definition we just gave, is this a pure function? Thanks for the follow of Volcano Gamer. Let's see it in the chat. Thumbs up for pure function, thumbs down for not a pure function. So actually, let's do this. I see no responses. Don't respond. Don't respond. We're gonna do something else. Okay, let's say I have something like this. We'll say let a equals 10. We have this function called add that takes in b, and then it returns a plus b. Okay, before it was a pure function. Now this we can call add with 10. And if we log this, we should get back 20, right? Let's start up Quokka. All right. Is this a pure function? The Twitch chat is broken? Gosh darn it. Hey, I'm waiting for chat responses. I guess everybody's responding on Twitch. Could not connect to server. Reconnecting in 1 second. Dang it. Ed says no. Oh, this is lame. Wait, is Twitch chat still broken? Dang it. This is the chat server, right? This is so lame. Okay, I'm gonna debug this. I want Twitch chat working too. Man. Okay. This. Twitch chat is still broken. Okay. Oh, you know what? Oh no. I think I'm listening unauthed. Right? I create a yeah, I just create a Twitch client, and it's listening on the Coding Garden channel with no auth. Is Twitch IRC down? Wait. What just happened? I don't know. Like, the thing is, I should see Twitch debug logs. I should see this. I should see that it connected to the server. And I'm not seeing any of that. Okay, just a second. There we go. It could have been my VPN. There we go. It's working now. Jeez. Jeez. Thank you, Bo. Hello, Jack Skelly. Welcome. If you type ! VS Code, you will see all of my VS Code settings. Okay. But Eddie says no. Harsh says they learned about vanilla JavaScript and functional programming concepts. I type and talk fast, you're right. Lynn says no. Shady might have been behind. Ka says no. But yes, this is not a pure function, because if we pass the same value into it, it's possible that we're not going to get the same value back, right? So right now it returns 20. But what if I did this? A equals 30, or yeah, let's say A equals 20, and then I call the function again with the value 10. Now I get back 30. So add is not a pure function because it's using things from outside of its own scope, right? It's using this variable, which could be changed by other code, resulting in a different value when you invoke the function. So this is not a pure function because it uses things from the outside world. And one of the tenets of functional programming is pure functions. And one of the benefits of that is you can be sure that if you call a given function, you're always going to get back the same result. Whereas if you allow things like this to happen, you could possibly get back a different result. So pure functions, that's the first thing. So, and how's the poll looking? Lazy chain. That looks like it's gonna be the one I do. We can get more votes though. There's a lot more people watching than voted. So if you're just showing up, please vote for which kata I should do right now, while I talk about the basics of functional programming. Do another pure function. Sure. Yeah, so, I mean, I could, let's do this. We'll have a function called emojify that takes in a name, and returns that name plus seedling emoji. Is this a pure function? Yes, because like no matter what I pass into it, I'm always going to get back the same result. It doesn't use outside variables. So if I say emojify with CJ, I get back CJ thingy. But if I call it again, I'm going to get back the same result. And if I call it again, I'm going to get back the same result. I always get back the same result no matter what I pass into it. These are very, very basic concepts, or it's very basic functions. But this is a pure function. Thank you, Heck. Okay, cool. So I think we got what a pure function is. It always returns the same thing. It doesn't use anything from outside its own scope. This is a fun little cartoon from Jayovsna. What is a pure function? So it takes an input, you have this box, you get an output. A pure function is a magic box that always gives you back the same output for a given input. Easy enough. Cool. And so we wrote a few pure functions. The other thing is referential transparency. So let's talk about what this is. An expression is called referentially transparent if it can be replaced with its corresponding value without changing the program's behavior. This requires that the expression is pure. That is to say, the expression value must be the same for the same inputs, and its evaluation must have no side effects. An expression that is not referentially transparent is called referentially opaque. So like a mathematical function. Typically, mathematical functions are pure functions. I think. I don't know. I am no functional programming expert. And actually, did I see Danny in the chat? Yeah, Danny is here. Danny is a functional programming expert. He knows a lot about functional programming. Danny, is every math function a pure function? But here's a nice little comic about referential transparency. You can clearly see that the compute simple interests of 100, 0.05, and 2 can be safely replaced with the value 10. This superpower is called referentially transparent. Danny says it depends on what math you're doing. Okay, but lambda calculus is. Okay, that's good to know. So basically, a thing is referentially transparent if you can take that function invocation and replace it with the result, and the code would behave in the same way. And this is directly related to pure functions, right? So we have this add function. The fact that no, I changed it. Yeah. So this is the non-pure function. Let's write a pure add function. Function add with a and b, and we return a plus b. This is a pure function. Given some inputs, you're always going to get back the same outputs. And if we were to log like add with 10 and 10, we're always going to get back 20. And this is referentially transparent because in my code, I could write this and it means exactly the same thing. Like the meaning and the result of the code is no different. So because it is a pure function, it is referentially transparent. Cool. It has awesome benefits such as caching the value for a given input to the function and reusing it. So this is memoization, which someone asked about earlier, where basically, because we always know we're going to get the same output for any given inputs, we could create a cache that whenever we get some inputs, we can check to see if we've calculated that before, and then just return the calculated value instead of having to calculate it again. And that's known as memoization. Memoization. Would using math.random make a function not pure? I would think so. But actually, I think math.random isn't truly random. So, but I would say yes, because every time you call math.random, you're technically going to get back a different value. So yeah, I would say no. Okay. Math.random would make it impure. Math.random calls outside for information. Cool, yeah, so it looks for some seed value to generate that random value, something like that. Cool, all right. Next up is first-class functions, and JavaScript is a language that has first-class functions. So a programming language is said to have first-class functions if it treats functions as first-class citizens. This means the language supports passing functions as arguments to other functions, returning them as values from other functions, and assigning them to variables or storing them in data structures. the fact that we can store a function in a variable means that JavaScript has first-class functions. So this is known as a function declaration. It's not exactly a variable. We can kind of pass it around like it is one, though. But if you see people doing something like const add equals an arrow function with a and b, and that returns a plus b, the fact that we're taking this function and storing it in this variable, and then now we can pass that variable around. So let's create like a compute function that takes in an operation, and then performs that operation with 10 and 10. So if I say compute with add, this should give me back 20. Let's start up Kata. But I can't do that because add is defined up here. Let's comment this add out up here. Cool. So look at what's happening here. I have this function. I've stored it in a variable called add. And then on this next line, I have this function, which is also stored in a variable. But this function takes in a function and then invokes that function with the value 10 and 10. So you'll see on line 37, I'm actually passing the function into compute, right? I'm taking add and I'm putting it as an argument to the function. This is first-class functions. The fact that I can take a function and just pass it around, and this is first-class functions. This is also, is it high-order functions? Yeah, it's a high-order function because this takes in a function as an argument. But yeah, let's catch up. So how can functional programming do stuff if it can't change anything outside of the function? Typically, this is where you like chain function calls. And basically, and we're going to talk about immutability. That's where that comes into play, where instead of changing values, you always create new values. You always create a new value, but it's based on previous values. So you can still get similar results. It's just you're never changing anything. You're always creating something new. Basically, you'll create a copy of the previous value and change the copy or modify the copy. I'm not going to do the hardest kata. Doc is saying you can also do add AB for partial application. Yeah, so that's another functional programming concept. The idea that you have a function which returns a function which returns another function, and then you can create sub-functions that basically use closures to hold the previous values. Cool. Shady, yeah, so Danny is responding to them. Let's see what Danny has to say. You can make a functional program, but chances are either the program calling your program will do something impure, such as print to the console, perform some I/O, or take some user input among many other impure things, and that's okay. Ciao, Astanix, welcome. Is this currying? This is not currying. The partial application that Doc showed, that's currying. Let's show that. This is also weird. So let's say let's call it like create adder. This takes in a and returns a function which takes in b, which is a function that returns a plus b. This is currying because you have a function that passes into another function. I don't know, but the way this would work is you would say something like 10 adder, and that's equal to create adder with a value of 10. But you'll notice, yeah, so then we could do something like this to get this. Wait. Nope. To get it to work, we could do this. We could pass in create adder, but then we would have to do this because create adder returns a function, this, which takes in a value, but then when you invoke that function, so the result of invoking this with 10 is going to give us back a function here that takes in a value, but now we've stored the value of a as 10 from before, and now when we invoke it again, that's going to give us the value 20. So this right here is currying. Cool. 42. Who said 42? All right, let's see what else I have to talk about, and let's see where the poll is. I'm going to share the poll again. Keep on voting. Did Merchan drop a custom image? I think he did. Keep on voting. Okay, so that's first class functions. Then you have higher order functions. So a higher order function is a function that takes one or more functions as arguments and returns a function as its result. So this compute function is a higher order function because it takes in a function as an argument, right? Create adder is a function, so we're expecting that operation is a function. Create adder is a higher order function because it returns a function, right? When we invoke it, we get back a function. More water? Wow, time is going by so fast. Morning Sage says, does it perform well to do a, which is a function which takes in the value a, which returns a new function? You're definitely gonna have some overhead because you have to the function calls have to be pushed onto the call stack. So I would say so, but yeah, I don't know for sure. Yeah. All right, and then you've seen these higher order functions before. So for each, map, filter, reduce, find, sum, every. The fact that for each accepts a function as an argument means that it's a higher order function. So with for each, you pass it a function, and under the hood, JavaScript's going to call that function on each element in the given array. But the fact that for each takes in a function makes it a higher order function. Cool. And then this is immutability, which I wanted to talk about. So an immutable object or unchangeable object is an object whose state cannot be modified after it is created. This is in contrast to a mutable object or a changeable object, which can be modified after it is created. So in functional programming, you don't ever change anything. You always create a copy and change the copy. You never change the original thing. And so if you think about it, this idea of having like very predictable functions, right? Because they're not affected by the outside world. The fact that you have referential transparency, so you can essentially just replace a function invocation with its value itself, and the fact that we're not modifying anything, everything is completely and totally immutable, results in potentially fewer bugs, because you have less moving parts, and you're more strict about how you code, and so this is where it comes into play as to why it's useful. So pure functions are predictable and easier to understand. I mean, this is relative, but for the most part, I would say so. Testing is easier. You do not have to depend on external state. So if you're ever writing unit tests, you don't have to mock a bunch of dependencies. You basically just pass the thing into the function, and it should work. I mean, you would probably still mock some things, but yeah. Debugging is easier. You can better isolate and debug a problem because you have a lot of small functions. Programs have fewer moving parts, no global state, mutable variables, or hidden state. Programs are usually more concise. That's also relative. And if you're not used to it, you'll learn to think about the solution to problems in a different way. This is the main thing for me, because learning about this idea of being able to pass functions around, you can do some really cool things, which isn't possible in a language that can't do that. So I'll share these resources. That's the basics of functional programming. Any questions? Hopefully the person that asked that question, that gives you some better light into what functional programming is. But yeah. And Doc says, functional programming might look inefficient to start with, but pure functions can be evaluated in any order lazily and can be optimized to heck and parallelized by the compiler because they have no side effects. Yeah, so that's the other thing. This idea of referential transparency, sure, you might be invoking functions a lot, right? And someone mentioned it earlier, like, is this less efficient? But the compiler and the runtime can make it more efficient because if it knows that it's a pure function and it's always going to give back the same value, it could potentially replace the function invocation with the value itself ahead of time. Yeah. Merchan is saying, this reminds me of LTI systems and how the impulse response of an LTI system describes that system completely. Therefore, when you know the impulse response, you automatically know the response to any input. What is an LTI system? Linear time invariant system. Investigates the response of a linear and time invariant system to an arbitrary input signal. Yeah, what field is this used in? Spectroscopy, seismology, circuit signal processing, control theory. Huh. Very cool. Heck is saying, is it good to be dogmatic to one side or the other? Or is it cool to have some stuff that is written functionally and some stuff that isn't? That's what I fall into. Some stuff that is and some stuff that isn't. I have met people that believe everything should be functional. Everything should be immutable. What the heck are we doing mutating state all the time? And I disagree. I feel like you should be dogmatic about it. Or not dogmatic, pragmatic. Don't be dogmatic. Be pragmatic. Please solve hacker rank. Maybe. And hello, Jana Lagata. Welcome. Thanks for the follow, Mihai Kozer. All right, let's see where the poll is. All right, I guess it's lazy chain. We're calling it. We're gonna do lazy chain. Morning Sage says, I love functions, but I come from C#. Yeah, well, with C# you have lambda functions, right? It's somewhat similar. Yep, we're gonna do lazy chain. Okay. Let's just read it. So method chaining is a useful technique in JavaScript, allowing better composability and readability of functions. One problem with standard JavaScript chaining is that chain methods are immediately executed upon creation. So, for example, if we take this, this is like, it's doubling the array, and then we call reverse, that returns a reversed array. The problem with this is that it opens values up to possible mutation before being called. Okay. To combat this, we can create a function lazy chain that accepts an argument and allows chaining, but delays execution to when the value method is called. Interesting. So lazy chain, you pass it in an array, and then you can say .invoke, and it will take in the function you need to invoke with the arguments to apply to it, and that should return some new array, or I guess some new thing that can then also be invoked and return reverse. This is somewhat similar to the functional SQL thing I implemented a few weeks ago. And so when you call a.value, that will execute all of the invocations and give you back a new array. Cool. So your task is to create the function lazy chain, which accepts any value and allows method chaining through the use of invoke and execution with the value method. Keep in mind that invoke is general enough to accept any prototype methods from the standard language. Okay, so I guess we're assuming that it's going to call functions on the thing, it's on the prototype, on the thing that you're passing in. So we would call to uppercase on the string or split on the string. But in the case where we passed in an array, we would call map on the array or reverse on the array. Okay, so this doesn't look too bad. I can kind of wrap my head around this. So let's do it. I'm going to rename this to Scratch. All right, new file. lazychain.js. We have our function. And we have a couple of examples. Okay, I think really we just want this. And we also just want this. And for this, we're just going to call console log instead of having tests. Cool. So if we start up Kata, we should see cannot. Well, actually, what error should we see? We see cannot, but what cannot what? You get a gold star if you can tell me. I'm gonna catch up. I didn't see your question about life. I guess I didn't. And it's okay. So the thing Merchan mentioned earlier was about signal processing. Thanks for the follow, Heartland. Oh wait, did somebody get a really high score? Oh, look at the leaderboard: a 99, a 97, a 96, a 95, and a 93. We have to make this game harder. Yep, and Morning Sage is mentioning Lambda and Link. So I did C# for a while, and yeah, when I learned about Link, that was super cool. It's the language integrated query, uh, integrated query language or something like that. But it's almost like a SQL style functional syntax that you can use to operate on like lists. It's pretty cool. Joe is saying, can I please do a video about view test utils? One day, yeah. Iffy. Immediately invoked function expression. What's that about? You cannot into lazy chain. Yeah, immediately invoked function expression. There you go. That's so weird. The uptime command doesn't work on YouTube. Can someone do uptime on Twitch? Yeah, I don't know. Cannot read property of undefined. Cannot. Yeah, cannot read property invoke of undefined. That's the one. That's what it should be. Thank you, Alka and Majestic Eye. Everyone's doing it. But so lazy chain returns undefined. So this invocation returns undefined, and then we're trying to say dot invoke. You can't get the property invoke of undefined, so cannot read property invoke of undefined. Very good. Gold stars for everyone. Water time. Yep. I feel like I should take better drinks. Hello, Cedric. I'm doing pretty good. I just decided to take a week of vacation, so this is going to be my last stream for about a week or so. I'm feeling good. I feel it's almost like a weight lifted. Like I don't have to go to work tomorrow. I can just rest, get caught up on like housework and stuff like that. Okay. So the first thing we need to do is this function needs to do some gardening. It's actually really cold. Well, it's not that cold. I think it's too cold to do gardening. Everything's gonna die, where I am, anyways. But so this function needs to return an object, right? That object needs to have an invoke property. So let's get that going. I think I might do this similar to how I did functional SQL, where we actually return like a class instance. I feel like that kind of gets out of the idea of functional programming, though. Okay, I'm not going to do that. So basically what we need is lazy chain needs to return an object that has the invoke function on it, right? And inside of here, we can create invoke, which is going to be a function that takes in the function name and then any arguments to that function. And then it needs to do something. So do something. So that's great. Now let's see what our error is. Cannot read property invoke of undefined. So basically, this call to invoke technically worked, but then this function returns undefined, and it tries to go on to this next thing, which chains it. So basically, each function we write or invoke needs to return this object so that it can be called again. So basically what we need to do is store this object in a variable. So let's call this the chain. And this is going to be an object that has... Well, this is going to be tricky because basically it needs to return invoke itself. I guess technically I might be able to just return invoke here. So inside of invoke, it returns itself. Now, this isn't a recursive call, right? Because we're not invoking invoke. We're just invoking, we're returning the function so that it can be called later. Here. Let's see. Lazy chain.invoke.invoke is not a function. I kind of feel like I like my go-to here is a class with like some internal state, but I feel like I shouldn't do that because we're doing functional programming. How many weeks of vacation do I have a year? Technically, I have unlimited, so I work at a company that has unlimited PTO. I've only taken 6 days of vacation this year, though, so that's why I was just like, I need a vacation. Doc says, is there any way to turn split into a function split without calling eval? Yeah, you could say array dot prototype at split, and that's going to give you back the function split. No, string dot prototype, and that this should give you back the function. And the only thing with that is we need to do this. So this works. Basically, we get the split function out of the string prototype, and then prototype functions need to have a bound this value, so we bind it to the thing that we want to invoke it with, and we invoke it. Maybe that'll help you, Doc. I don't know. I'll leave that on the screen so you can see it for a second. No work, no streaming. That's the plan. We'll take a big break. This kata is called Lazy Chain. Here, I'll link it in the chat. I don't know if I did that. Thank you, Cedric. So it's like, you got this. I believe in you. Thank you. And thanks for the sub, Emilio. Thanks for the sub, Shivam. Thank you, Mr. Annual. I appreciate that. Does JS have something similar to args in Python where a function can take a limitless amount of parameters? Yep, so that's what I did right here. This is called the rest operator. And what this says is the first argument to this function we're going to call name. I mean, technically, I could do this, which basically says any arguments that get passed into this function go into this thing called args, and now that's an array. And I could say like name equals args at 0. So this is the spread operator. That's one way of doing it. Before the spread operator existed, there's literally a thing called arguments. And that gives you access to all of the arguments that were passed into the function. But this is the more modern way of doing it. Thanks for the follow, P-Seal. Hola, and okay, we got some weird stuff going on. I think I can't make this because like it's trying to return itself before it's defined. I think I need to actually make this a function and not an arrow function. Like this. Yeah. Let's see. LazyChain.invoke.invoke is not a function. And we also need to return value. And value is going to be a function. And it's still broke. You're welcome, Lion. Let's write this on a separate line. So LazyChain.invoke. Comment that one out for now. So we pass in a lazy chain with the argument. Okay. And then we call invoke with 2 uppercase. I mean, it kind of makes me think we need to store some like internal state, like I don't know, like just say let final value equals nothing to begin with. And then when you call invoke, we are going to take in the name and the rest of the arguments. And then we need to set final value equal to the argument at that function that we're trying to invoke. And we're going to invoke it with all of those args. And then we'll return invoke. And then this needs to return the final value. Cedric182 with the $2 super chat. Thank you so much. Let's see. No message, just a thumbs up. I appreciate it. Thumbs up. Cool. Do I have to return the lazy chain? So this returns an object that has an invoke property. Yeah, I need to return this whole thing, right? Yeah, I need to return this. Um, yeah, this is super weird. So let's call this the chain, and then we return the chain inside of invoke, because that itself needs to have the value on it. Cool. So yep, and I think we'll do this. Let's say final value, the initial value is the argument itself, and then each time we are overwriting it in using the previous value. And I think I'm done. I think I've done it, but yeah, I'm done. This is it. This is all it took. Though, how can we make this better? These functions look weird, don't they? Like, how can I make this better? Please help me make this more functional. Because this did it. So basically, lazy chain returns an object that has invoke and value on it. Great. That takes in an argument. Boom. And we have this value that we're overriding, because basically whenever we reach for the value, we want that final value. Technically, we could do something like push these invocations into a stack, or like into an array, and then when we call value, actually execute them. I mean, that's one way to do it. Yeah, Danny, what ideas do you have about this while I drink my water? How do we make this more functional? And I totally forgot to turn the drop game off. Is this is the drop game what's the word? Distracting to my coding? Or is anyone like does no one care about the code? Are they just here to play the drop game? Excuse me. Code schmode. Everybody's just here for the drop game. That's cool. That's cool. Coding is a side attraction at this point. It's so true. I need to make more fun games for people to play. So Danny says, I'm wondering how the test is going to test the laziness of it, because it seemed like it shouldn't invoke anything until value is called. Yep, that's what I was thinking too. Let's just throw this into Code Wars and see if it works. But you're right. We need to make this. We need to make this so it doesn't actually invoke the functions until the value is called. And I don't know how it would even test that, but here's my thought. We basically need another what do you call it? A place to store each of these invocations, right? Yeah, so let's say, I mean, this isn't exactly the chain. Kind of is. Yeah. Invocations is going to be an array. And then instead of overwriting it here, we just, invocations, we push an object that has the name and the args. Like that. And then now, yeah, we don't need this variable anymore. But now when we call when they invoke value, we basically have to iterate over the invocations array and invoke each one. So we'll say return invocations.reduce ultimately. That is going to take the final value and each invocation, and it starts off as arg, but each time we will return the final value at invocation dot name invoked with, let's take a quick stretch. This is definitely eager evaluation. Yep. Shady says, I wouldn't understand what's going on even without the drop game. It feels like a classroom with paper planes flying around. Yeah, it's true. It could pass in spy functions that make sure they aren't called. That's true. Yeah, yeah. You can put the return before the functions. That's also true. Cedric182 with a second super chat. Come on, man. Thanks so much. Cedric182 says, I don't know what super chat is. Well, you're giving me money. I don't know if you meant to do that, Cedric, but I appreciate it. And thanks for the follow, Mama6. Welcome to the stream. Yep, so now we can invoke this with invocation.args. That should do it. Yeah, it still works. So now, when we do an invocation, we're storing that and then using it later. That said, this really isn't a pure function because we're modifying this external variable here. And what Alka mentioned is technically I could return chain. Well, wait. If I return chain at the, wait. Put the return before the functions. Interesting. I don't. What do you think of this, Danny? Yeah, that's very true, Alka. So basically, even though we've defined these functions below the return statement, they technically will get hoisted to the top of the scope, so they will still exist and be accessible. Danny's saying, I don't think there's a way to make a pure invoke. Okay, that chains. Okay, so yeah, I think we'll go with this. Done. That was fairly easy. Hopefully somebody learned something from that. Let's try it. Still works with the sample tests. A monad? I don't know. I don't even know what a monad is. Yes, what a beautiful garden you have all grown. Look at that. It's so beautiful. Oh, in a bath. Cool. It worked. Oh, it does check the laziness. I wonder what that was doing, but yeah, it probably makes sure that you don't invoke it before value is actually called. Cool. So that was fun. Should I do another poll, or should we just pick the second most voted one from this poll? Or should we vote on a 4Q? Wait, that's not it. Straw poll. So the second most voted was Church Booleans with 5 votes. That one seemed very tricky. In the chat, let me know. Should we do Church Booleans or should we vote on a 4Q? There are not enough votes. Okay, yeah. Revote. Revote. Let the Senate vote. All right, we're gonna do a 4Q. We're gonna get a little bit more difficult. So we're gonna stay in the functional programming category, but now we're gonna go down to 4Q. Yeah, we still have functional programming selected. Route calculator. This calculator takes values that could be written in a browser's route path as a single string and then returns the result as a number or an error message. Route paths use the slash symbol, so this can't be in our calculator. Instead, we're using the $ symbol as our divide operator. You'll be passed a string of any length containing numbers and operators. So add... Chad voted Church Booleans. YouTube is like 30 seconds behind. We've already decided on the 4Q. I'm sorry, Chad. So you'll be passed a string of any length containing add, subtract, multiply, and divide. Your task is to break the string down and calculate the expression using this order of operations: division, multiplication, subtraction, addition. So it's basically an expression parser. Oh yeah, absolutely. The other solutions for lazy chain. Let's absolutely do that. Where was I? Yep. Okay. So, this person, and I mean, calls. These are like invocations, right? Um, Instead of creating a variable for it, they have it as a default parameter. It's the same thing. They're still technically mutating state. And thanks for the follow, Lanavel. Welcome. Yep, they did a reduce very similar to what I did. Cool. This one is it though? It like it oh, so I guess that's how we could make it functional. Basically, um we don't push into the array, we overwrite it with a new array because that's what they're doing. Um this is a monad. Justin, $2, $2 super chat. You all are too kind, too kind. Justin says, gratis from YouTube to show thanks to talented creators. I appreciate that, Justin. Thanks for tuning in. Okay, so this is a monad. Let's look what it's doing though. So, and we can compare it to my solution. So, invoke takes in the name and then a number of arguments. Similarly, this takes in the name and then the number of arguments. But then it's a recursive call, which overwrites calls, and it returns itself. I see. Let's make my function do this. I think I understand. So if we say invocations is now the array here, and then basically we want to keep this without pushing into it. So it's water time. Someone take over me. I'm going to bed. All right, bye Heck. Bye Heck. Thanks for helping out. See you later, Willie Lumplup. Thanks for tuning in. All right, I think I can do this. Because at this point, value can just be defined here, like that. So that goes away. And ultimately, we just want to return this object. And instead of pushing the invocations, we will invoke lazy chain with this. So we need to we basically return a recursive call. Lazy chain. We're going to pass in the same argument, but we spread all of the previous invocations and include this particular invocation. And that works. I've just created a monad without knowing what a monad is. Is this a monad, Danny? But that makes sense because like it's okay to do the recursive call here because basically all the recursive call does is return this object again, but now invocations keeps the state of the previous call because we've changed that parameter there. Cool. Look at me. I'm learning monads. That's pretty cool. I like it. Looks like they did the same thing here. And yeah, so this person basically did what I did. We're modifying the array and then returning this, which ultimately is the object itself. Cool. Well, and then instead of a reduce, they just called each function manually. 4Q because I nailed the 5Q so well. I'm gonna do a 4Q, and that expression evaluator looks pretty tricky. It's a very similar. Lazy chain prototype. They're returning an object with that prototype. That's unnecessary, but it basically does the same thing. Same thing. There are not a lot of original solutions here. So make chain takes in the chain. Okay, this is a similar thing because they're calling make chain so that they can keep the state of the chain. Yeah, it's all good, Merchan. So Merchan says, I was going to suggest using an argument to store the call stack, but then I thought this is not recursive. We're chaining stuff, but it turns out my thinking was in the right direction. Yeah, it's super interesting because basically the recursive call just returns an object. So it would never really be like an infinite loop, right? It just returns the object itself, and then it's up to the outside world to invoke those functions, which actually make the stuff happen. The fewer the lines, the more correct the answer is. Thinking functionally is hard. It's hard for me too. Yeah, it's something I gotta learn. Let's see. Yep, and they basically used object-oriented style where they have an instance property which is an array of the chain. Cool. Okay, so if you're given any invalid input, so this is the one where you're given a string that has some maths that you have to parse and evaluate. Operations are infinite. Order of operations is imperative, no eval. So given 1 + 1, return 2. Given 10 divided by 2, return 5, etc., etc. And then you get tricky things like this. Was that an 8-ball emoji? That's pretty awesome. Where you have to evaluate it. Parameters outside of this challenge. Okay, so we don't have to worry about brackets, square roots. Wait. Bad mathematical input. You may have to deal with floats. Okay. This is not that bad. Because some of the harder katas that I've looked at before, you have to take into account parentheses, and that requires like some parsing. Whereas this one, we basically could iterate over it and find the things in the order of operations, like first do all of the multiplications and the divisions and replace their values, and then do all of the additions and subtractions. So that sounds fun and that sounds doable. Let's find some more 4Qs and then we'll vote on it. Haskell list comprehension, number 2. You should solve the previous part. What's that one? It's a 5Q. Haskell list dot notation. We'll skip it. Currying versus partial application. Currying and partial application are two ways of transforming a function into another function with a generally smaller arity. What does arity mean? In logic, mathematics, and computer science, the arity of a function or operation is the number of arguments or operands the function takes. Okay, so we're reducing the number of arguments or function, or the number of arguments that a function takes. Doc says do that one. Okay. Currying is the technique of transforming a function that takes multiple arguments in such a way that it can be called as a chain of functions, each with a single argument. Okay. Partial application is the process of fixing a number of arguments to a function and producing another function of smaller arity. That's good to know. Yeah, you can call dot length on a function in JavaScript and it returns the arity. That is the number of arguments that the function takes. That's pretty awesome. Okay, that one looks fun. Curry me softly. Caveat, currying is not exactly what is described below. Stretch your mind. Okay. Create a function which accepts a single argument of another function and returns a curried version of that function. Yeah, so that one's kind of just like currying. Let's look at functional streams. Infinite sequences are common. Natural numbers, for example, are defined in such that they always have a successor. In Haskell, most of the time lists are used to model infinite sequences. But why should we check for the empty case if it will never occur? Streams offer an elegant alternative to model infinite data. Okay. Are we doing thunks now? In pure functional code, data is not mutated. Every reference is immutable. Calling a function won't change any state and should always return the same value. So write heads. Take a drink of water. Is the user lazy thunk? Oh, I didn't know that. That's pretty cool. The person in this emote, I think, is what you're saying. Okay, write heads, which returns the value of the head of the stream, and tails, which drops the first value of the stream. I don't even know what that's asking for, but we'll put it on the voting list. And then born to be chained. We did just do lazy chaining. Let's see. Function composition is a powerful technique. For example, but in complex expressions, composition may be difficult to understand. In this kata, we will implement a function that allows us to perform this by applying a fluid style. Yeah, that's pretty cool too. Okay, let's vote. Lazy Thunk, aka Kappa. Very cool. Gance 182 with the drop, and he just missed it. Oh. Okay. Which for Q should I do? First option is a route calculator. Second option is currying versus partial application. Born to be chained. Functional streams. And curry me softly. Every 90 seconds you can drop. Cheddar says, I'm switching to Twitch next time. YouTube feels so far behind. I'll stand here in silence for 30 seconds, and that means you can switch to Twitch right now, and you won't miss anything. How does that sound? Let me know in 30 seconds when you hear this message. This will split my curry. But yeah, you gotta pick which one. Pick one. For those of you just joining, hello, Hippoviva and Finuk. Exclamation mark drop is the command you want. Okay, this is it. Here we go. Potentially the last kata of the night. Come on. Rich, that program is called Timeout. It's a Mac application. If you do exclamation mark break in the chat, oh, I'm here, I can do it. That will give you a link to the break timer. Have we started yet? I'm feeling lost. No, I mean, let me know. Okay, so we're going to take 30 seconds of complete silence to just reflect on our day. So everyone, join me if you'd like to. But for 30 seconds, we're not going to type drop. Yeah, we're not going to type drop. We're just going to sit here. I mean, you can type drop if you want to, but if you're joining me in this, we're just going to sit in silence for 30 seconds. We're going to start over because that was not silence. Wait. Starting now. feel like that went by really fast. But that was 30 seconds. Looks like the route calculator is winning. But we've only got 8 votes, so it appears that quite a few people are watching. I don't know how many are bots or how many are just here to play the drop game. But please vote. Wait, what did Jack Skelly do? Oh, I see. Yep, Andrew Lane did it too. Carol Linda voted. That's good. Help? Did you mean hello? Leaves the room. Bob is working on a 6Q. It's their first kata. Helga says I specifically did not vote. That's okay. It's not mandatory. Totally Sane did their first kata their first 8 kata a week ago. Awesome. Should we call it for route calculator, or should we wait for more votes to come in? I gotta look up the chords to Somewhere Over the Rainbow. I don't know it. I really only know I know 4 chords. I could figure out other chords, but C, F. Which one is that? It's not on this chart. Then I know G. Okay. Somewhere. Wait. Over the rainbow. So, somewhere over the rainbow, way up high, there is a land that I've dreamed of once in a lullaby. I feel like these words are wrong. This is like this is the one by this guy. Wait, what's the difference between E major and E7? It sounded like an Obama impersonation. Oh, Andrew Lane with the 99.6. Great work, Andrew Lane. That's unfortunate, Chad. Yeah, Chad is saying Twitch is skipping when they cast it to the TV. Dang. He is, yeah, he's like the most popular ukulele player. Merchan says E7 is jazzier. So this is E major. And then this is, wait, 1, 2. Jazzier. Someone type hydrate. I drank when we took our 30-second moment of silence. Somewhere over the rainbow, way up high, there is a land that I've dreamed of once in a lullaby. I feel like these chords are wrong. How's the poll doing? Route calculator is still winning. um, that was oh, thank you. That was I feel like it probably wasn't, but I appreciate that. Good job. I gotta find like with that chord change. Once in a lullaby. Once in a lullaby. Wait. Way up high. And the dreams that you dreamed of once in a lullaby. What is an A? What's an A? Oh, that's easy. Once in a lullaby. See, A major and then F are just like too close. It's in a lullaby. I want a different chord for that. I used to be able to. I can't anymore. I was in band when I was in high school, so I learned how to read sheet music. Yeah. This is the same thing, A and F. It just doesn't work. Someday I'll wish upon a star. Wake up where the clouds are far behind. Where trouble melt like lemon drops high above the chimney tops. That's where you'll find me. Oh, somewhere over the rainbow. Bluebirds fly, and the dreams that you dare to, oh why can't I? See, that the A to the F thing, I don't know. Let's solve a kata. This is getting weird. Yeah, guitar is fun. The Jake Shimabukuro version. Okay, let's look that one up. Maybe that has better chords. Somewhere over the rainbow. Oh, I'm pretty sure I've seen him do a lot of... Is he the guy that does ukulele with like effects pedals and stuff like that? Yeah, I think this is him. He's awesome. Yeah, they're too close. Too close. Not that. Not that. Nope. In F major. I now have a simple... Will it? I feel like I tried to add that bot before and it didn't work. But if it's here, that's great. Thank you, Majestic Guy. Oh, it's your... Did you just write it? That's awesome. Okay, we're at a loss for Somewhere Over the Rainbow. We're going to do the route calculator. It's going to be hard. Sort of. I don't know. Might not be that hard. All right. Route calculator. Let's create a new file. Route calculator.js. Take in our calculate function. And we'll bring all of these wonderful tests. Oh, Doc has the really spicy chords. Okay, let's try it. Actually, I mean, those look complicated. C6, A major 7, E major 7. Should I try it? Emotes in the chat if I should try it. Do it. Try it. Okay, could you send me a link possibly, Doc, that has like the chords on it? Okay, let's look for just ukulele. Ukulele. The lag. Chords. Turn it into a music channel. Hello. Omar is my blooming name. Welcome. Post it in the Discord. Okay, let me pull that up. Spicy. Live chat. Oh, it's PDF. Are you gonna hack me, Doc? Please don't hack me. Oh man, why can't I just open it in Chrome? Oh, I guess I saw this earlier too. I can't really read this music though. Does it have the lyrics on it? Oh, it actually has the tab. Huh. Oh, wait. Fifth? Okay. So, yeah, it has tabs. Where does C6 come into play? No idea what I'm looking at. Free time. That's a really nice garden we got going on there. It's really cool. You all are great. Yeah, where's the strumming part? Well, I guess he picks it, does like, or he finger picks it, but I think so. But I can't understand this sheet music. You mentioned it started at a C6? Maybe I need to just listen to him play. Actually, like, will I get a copyright strike if I listen to him play it? Here's what we're gonna do. We're gonna go on YouTube and find a Somewhere Over the Rainbow ukulele tutorial. We're all gonna learn together. Ukulele easy.
Songs. There's a lot of really cool things you can. So you should know the song order. The song goes first the instrumental intro, the intro with the oohs, which some people call the bridge because it had a C chord. Song we're gonna need a C major.
Doc posted some simpler. Yeah, this is just. I mean, this is kind of turning into a chill stream, but that's okay with me. You all are fun to hang out with. Here's a simpler one. Ooh. Are they the same chords though? As the one I was trying to do earlier? Oh, this works. Yeah, I think that was missing. So instead of like the A to F, it's the A7th to D7. How does that work? Because I can bar it. On the second and third. Heard of once in a lullaby. Cool. That's all good, Carolinda. Carolinda says, all the katas today are way too hard for me to understand. I'm just going to be here for the drop game and working on the drop game. I try to copy from you. Sicken up you are way too hard. That's okay. I'm glad you're hanging out. This was the real code kata to solve. Yeah, finding the right chords. Wait. Somewhere over the rainbow. Oh, over the rainbow. Way up high. Wait. No. That's a E7. That's this one. Wait. Was that a new score, Andrew? 99.6, or was that one you already had? I have not worked on tab editing or music software. That would be fun. Yeah, that would be fun. Oh, wait, okay. And this is, yeah, this D7th and the E dim 7. I don't even know what that is. Those ones are tricky. Someday I'll wish upon a star. You know what I can do? Check it. I'm going to sing Over the Rainbow with the chords that I know. I'm just going to change the key of singing it in. It's the key that I'm singing it in. Let's try it. Yeah, so right now, all of the scores are just stored in the database, but they have a time created on the scoreboard that you're seeing right here. There's a time created on it. So what I can do is only show the scores for today, or like the day that I'm streaming on. But now we have a history of scores. Dim stands for diminished. Okay. Hello, Krisu. Somewhere over the rainbow, way up high, there is a land that I've dreamed of once in a lullaby. Someday I'll wish upon a star, wake up where the clouds are far behind. Dope remix, yeah. I can sing. Okay, somebody name a song. I'll look up the lyrics and I can use those chords to sing that song. I will do that right now. First song to pop up. It's time to hydrate. Thanks, Majestic Eye. We're losing viewers. I think that's okay though. Oh yeah, I'll do that. Not bad. Thank you, Morning Sage. Play Hey Jude. Well, Alka already recommended Never Gonna Give You Up. Metallica 1. Here we go. You're all about to get rickrolled. We're no strangers to love. You know the rules, and so do I. A full commitment's what I'm thinking of. want to tell you how I'm feeling. Gotta make you understand. Never gonna give you up. Never gonna let you down. Never gonna run around and desert you. Never gonna make you cry. Never gonna say goodbye. Never gonna tell a lie and hurt you. We've known each other for so long. Heart's been aching, but you're too shy to say it. Inside we both know what's been going on. We know the game and we're gonna play it. And if you ask me how I'm feeling, don't tell me you're too blind to see. Never gonna give you up, never gonna let you down. Never gonna run around and desert you. Never gonna make you cry, never gonna say goodbye. Never gonna tell a lie and hurt you. Deep web, 33rd level. We made it, everyone. Okay, I think that's enough ukulele. Let's try to solve this problem. Hello, Geo. You came at a very interesting time, but welcome. Okay, so, let's keep this because we know these are the, Oh, I didn't discover that doc. That's pretty funny though. Can I help with this? I could try. Let's see real quick. But basically, this is our legend. That's what each of those symbols means for our calculation parser. Query selector for canvas, like it's like a street musician. Thanks, Mattia. So is this part returning null? Well, yeah, I mean, yeah, make sure you have a canvas on the page, and then get context 2D, that's returning null? That's super weird. I don't know, Valentin. I'm not super familiar with canvas, but I mean, it should have a context, right? I don't know. If you have a code pin, might be able to help you with that. Programming / busking, yeah. My YouTube viewers went from like 36, now it's down to like 20. That's beautiful. Okay, so we have I don't want to call that sum. This is really like the query, let's call it the route. Basically, we need to parse the route to pull these out and perform the calculation. They don't understand art. They don't see the beauty. You're right. Hello, George. Welcome. Okay. But also, you all got rickrolled. Maybe they got mad because they got rickrolled. I bet that's what happened. Bet that's exactly what happened. Okay. So how are we going to do this? We could parse it character by character and push it into like a stack of operations. Yeah. And thanks for the follow. Omar is my blooming name. Welcome. Give it to me, Mao is saying, where would you recommend starting with JSLint tools? Just in terms of setting it up. I might have a really old YouTube video, like a YouTube video from 2 years ago on how to set it up. But first, make sure you have the plugin installed in VS Code. There's the wait, no, I use ESLint actually. I don't use JSLint. I use ESLint. So make sure you have the plugin installed, and then from the what do you call it? From the command line, you can install ESLint globally, and after you've done that, you can do ESLint -- init, and that will ask you a bunch of questions and then generate your linter file. Hopefully that's good enough. But Chris Cole, yes, this is a Kata. This is the one that we're trying to solve. Voted on by viewers like you. Okay, So, and we have to do it in the regular order of operations: division, multiplication, subtraction, addition. I kind of just want to look at it character by character. Yep, hopefully that helps. When using the view CLI, how do you get to the ESLint init phase? I can never get to that point of choosing my own style. Make sure you choose linter. I could show that really quick. Wait, where's my terminal? That's not it. Do I have any other terminal windows? View, create, test. So you should choose manually select features, and then make sure that linter/formatter is checked. And then this on this particular question, pick a linter/formatter. Oh, choosing your own style? I don't know if you can do that. Yeah, you have to choose kind of the pre-configured ones. I guess if you do, yep, yeah, I see what you mean. If you do with error prevention only, then so put it in dedicated config files. Let's let that run. I'll see it. Thanks for the follow, Theris. Welcome. I think we chose Airbnb because in our front end, Airbnb was using tabs, and in our back end, we wrote it our own, and it was using spaces. Yeah, so you can definitely write your own ESLint, but I wanna see there are things that you need in there, like the Vue plugin, and as long as you have those, then yeah, you can put whatever settings you want in there. Split on operator characters, then make 4 passes according to the order of operations. Beautiful. I was just waiting for somebody to tell me how to do it because I'm kind of tired. So that's how we'll solve that one. Yeah, let's look at this though and see what we got. So if we look at the ESLint file that it generated, yeah, so it has plugin, Vue Essential, ESLint recommended, and then you can add your own rules in rules here. But you can also just generate. So let's do this. Let's rename this to like original, and then we can just run regular ESLint init and answer the questions here. Answer questions about your style, spaces, single quotes, Unix, yes on the semicolons. So that created this. Oh, wow. It did it for me. Look, plugin Vue Essential. Huh. Say a two space tab. That might have actually done it. Let's see. Yeah, that did it. That's all you need to do. Just run ESLint init in the folder. It will ask you the questions, and then somehow it knows to automatically bring in the Vue plugin. That's pretty sweet. Did not know it would do that. Cool. Thomas is saying, what about storing the values on a binary tree? We could use some sort of tree structure, right? Because that would inform potentially the order of operations. I'm getting tired, though. I've been streaming for 2 hours. Wow. We have not done much this stream. Airbnb, the authority in coding practice. It's one of. Okay. We've done a lot. Yeah, I mean, sort of. I don't know. I'm tired. I'm tired, and the viewer count reflects it. Okay. But honestly, though, all the people in the chat right now, like, this is what we're here for, right? Mattia and Alka and Merchan and Eddie and this new person there is. Welcome to the stream if you're still here. Cool. Shouldn't force it gets some. Oh, we're gonna solve this one. That garden is pretty sweet though, right? That's a pretty slick garden. I guess if we split it on operator characters, would we lose those operations? Oh no. No. Okay, so let's think about this. Like if we first split on multiplication, we now know that all of the things need to be multiplied times each other. So then we resolve the individual things left over. I'm just going to try writing this. Okay, so let's say multiplications equals route dot split on multiplication. Multiplications. Let's start up Quokka. And so basically, we would iterate over this array and multiply those things times each other. But each thing inside of that, we then need to resolve the value. So let's say we have like, we'll store the result at the top. And then we'll say multiplications dot for each. Do I see recursion? Possibly. So we'll say like if multiplications dot length is greater than 1. Because if it's not, then we don't need to perform a multiplication. So if the length is greater than 1, we'll say multiplications dot for each. Yeah, I think we could do this recursively. For each, or not for each. Let's use a for loop straight up. For operation of multiplications. No, we need a for loop because I kind of want to do this times this. Yeah. Wait. Oh yeah, everyone should vote for this. Let's take a moment from code. Let's take a pause from coding. We're gonna go to this URL. I'll share it on YouTube too. But you should vote for the extension created by Alka and Instafluff. Submissions? Can I do it entirely by chaining splits and joins? Probably. Is there any way to link to the specific extension? There it is. Quick stretch. There we go. Thank you, Majestic Eye. So you can watch the video to see it, but essentially it's an extension where you can put it on your Twitch channel, and basically you can award in-game things using bits and stuff like that. It's pretty sweet. That username is taken? Who took my username? Weird. Oh, voting is not quite open yet, but you can like it. My skills include ukulele. Ukulele. Bad ukulele. My interests are in voice. No. None of these. Let's go. Definitely blockchain. Let's go. Yep. Nope. There we go. Give it some likes. Here, I'll share it on YouTube too. So you don't have to vote, but if this interests you, please throw a like. It will only help. Okay, back to coding. We're attempting to. So, if the length is greater than 1, basically we could do a regular for loop and increment by 2. So we'll do a for loop that I equals 0 while it's less than multiplications dot length, and we'll increment by 2 each time because we want to say result equals calculate of multiplications at 0 times calculate of multiplications at not at 0 but at I, and multiplications at I plus 1. So that's going to take those two things and multiply them. Let's test with a simple multiplication. Oh, like something like this. So 5 times 5 should return 25. So and then at the end of it all, we will return result. So we're going to split the route on the star. That's going to give us an array of length 2. And then we're going to call calculate with that. So if the length is greater than 1, that else we'll say result equals multiplications at 0, because that's going to basically take what was ever in there. And we can call this multiplications. Let's call this parts. Oh, we need to return a string though. That's super weird. Because if it's a recursive call, then it needs the string. I see. We started the result with 0, yeah, and so this is going to return 25, and then it's going to attempt to call. Well, actually, here's what we need to do. We need to put this all back into a string for the recursive call, right? I think. Wow, great job, Andrew. All right, I don't know if I like going down this path because we're going to get some like really messy, weird code. Starting the result at 1. At the same time, so if we tested that with 1, that works. If we test it with 1.1, that works too. If we test it with that, it doesn't work. So if we tested for multiplication, if we didn't find it, now we'll test for division. Let's do this. Split on the $sign. Very similar logic. Calculate divided by. So we initialize, yeah, I guess we could initialize it here. That makes sense. Because then we don't have to do that there. So, cool. And for basic division, should work. Great. And basic multiplication, it should work. Great. Now we need to handle addition and subtraction. So basically we just add it all together. So now, another nested thing where we check for, let's do addition. And else we need to do subtraction. Hello, Coding Pasta, welcome. So here's the tricky thing, though. It gives us 1 plus 1, and it does string concatenation. Copy pasta. So I think what we should do is coerce the results here into numbers every time we call calculate. Ultimately, yeah, I think this is what we need to do. Just turn everything into a number. I have a feeling we're going to get some nans in here, but let's just try it. All right, that worked. Subtraction works. That works. That works. That works. That works. This breaks. So the situation where we don't have an even number of operands. Yeah, let's see. Oh, I see. Should we do division before we do subtraction? And this changes to divide. I mean, technically, division and subtraction can happen in the same order. Is that true? So the thing is, we've got it for scenarios where we have the same number of operands. Oh, nope, that broke it. Okay, so Lion is saying split everything by $sign because division is most important, then iteratively by star. So by multiplication. And then do recursion on those subparts. Okay. I might actually not go down this route at all and look at it like one token or one character at a time. Let's look at what Majestic Eye is suggesting, though. Non-Twitch emotes that can be dropped. Getemoji.com. Oh, can you like copy and paste these? Is it the actual Unicode value? Nice. Here we go. Number one. Number one. Number one. Number one. How did I not get on the board? Wow. The leaderboard is insane right now. 99.6, 95.45. I didn't make it on the leaderboard though. Oh well. Cheating. No cheats. Though I should do, if the name Coding Garden is detected, it should just drop onto 100. Okay. I'm kind of tired and I don't want to do this. But here's what I'm gonna do. Like I don't like this recursive solution. To me it's like it's not making too much sense. Like I could probably figure it out if I wasn't as tired. But here's kind of what I want to do. I want to look at every single character in the route. So we have our result initialized to 0. And then we have a for loop that goes for each character in the route. because this is a string. And then we'll say token is going to be route at I, because that's going to be like a character in the string. And then we need other variables for, let's say like let current number equal nothing initially, and also let current operation equal nothing also. Thanks for the sub, Martin. Thanks for the sub, Lalilulo. Welcome. Alka has an emoji picker built into the eboat picker. That's pretty sweet. For console logging the result, I use a thing called Quokka.js. Quokka.js. QUOKKAJS.com. Check it out there. Cool. So yeah, we have current number and current operation. And actually, current number starts off as an empty string. And so does the operation. So, because basically like in the scenario where we're dealing with like 1.1, we kind of need to concatenate until we reach an operator. So we can say if token is, well, actually let's create an object that has all of our operations. So let's say like const operations, and that's an object, and then our keys are going to be all of the possible operations. So we have the plus sign. I mean, for now I'm just gonna put true, because I'm just gonna use this to detect if a token is an operator. True. Multiplication. True. I may end up putting the functions in here, but I'm just gonna go down this route. True. Okay. So we'll say if operations at token. So if that token is an operation, then we kind of need to push the number onto a stack or something like that. So let's do this. Let's say let calculations. Well, let's call this parts. Basically, what I'm going to do is split it up into the parts, but also maintain the operation that needs to happen. And then I can determine, I think, what order they need to happen in. So if we found an operation, then that means we need to push the current number and then set the current operation to be that thing that we just found. I'm blinded by Alka's glowy brain. So I think we can say parts dot push current number. And we'll parse it as a number, because we know at this point, because we reached an operation, it should actually be a number. Else, if it's not an operation, we'll say current number plus equals the token. Thank you, Majestic Eye Bot. It's good water. And actually, I don't think I need to store the current operation. I will push the number, and then I will push the token, because that is the operation itself. So the result of this loop should give us an array that is each number. So like let's comment this out. But if we look like in this example of 5 times 5 times 5, ultimately, whoop, we did something wrong. Oh, we need to reset current number. So we push the current number in, push the token, and then set current number back to an empty string. There we go. And once we've broken out of this for loop, we basically need to say if current number is a thing. Actually, it should be a thing. The last thing we find, it should be a number. We're going to say part stop push current number turned into a number. Cool. So ultimately, this gives us an array where we have all of the numbers which are actually numbers separated by the operations that need to be performed. I like this. We've at least, I'll leave that there for now. We've at least made it this far. Now we need to take this array and turn it into the correct order of operations. I've solved a reversed Polish notation calculator before. I'm curious if there's a way to turn this into reversed Polish notation, because if we do that, then it should be pretty easy to solve. I'm just gonna look that up. Let's say convert calculation into reverse Polish notation. My brain. Infix postfix converter. So I believe this is infix, and we want to go to postfix. Though I don't know if this will maintain order of operations. Convert. Okay. What about something like this? Anyone watching that understands this, will this maintain the order of operations? 5 times 6 divided by 2 plus 5 minus 10. So first we need to divide 6 and 2. So yeah, so when we get, well, actually, when we get, oh, no, sorry, this needs to, I need to make this a division sign. That's why it's weird. So this will multiply 5 and 6, and then divide the multiplication of 5 and 6 by 2, and then subtract that result from 5, and then add 10 to that result. Is that the right order? So if we're doing as they say, we have to perform division first. So if we do division first, this results in 3. And then we do multiplication, so this results in 15. And then we do addition, so this results in 20. And then if we subtract 10, the result is 10. Cool. So if I take this and put it into a reverse Polish notation calculator, I should get back 10. Thank you, Postal Rat. I should just try something super simple. Let's do it. So if I say 2 plus 2 times 2, so this will, yeah, that will do it. That will multiply 2 and 2, and then add the result. I think that's right. Oh, wait, I already searched for that. Let's search this on Google. Reverse Polish notation calculator. I just want to plug it in. Actually, you know what we can do? We can use one of the old code katas that I solved, because I have a reverse Polish notation calculator in there. Coding garden. No, dev. Code katas. And we'll use my handy Code Kata's website. I can do it without RPN, but I want to use RPN. Yeah, episode 6, I did reverse Polish notation calculator. I mean, is it wrong of me to want to use reverse Polish notation? The thing is, if we can simply convert something from infix to postfix, that makes it really easy to calculate. That's my thinking. Because otherwise we have to do weird things where we first find... Actually, never mind. Never mind. We're not going to do that. Here's what we'll do. I think at this point, now that we've calculated it, we can... it might be wrong to use someone else's code to convert to RPN. Okay. Wrong as in they didn't do it right, or wrong as I shouldn't use that. But let's think about this though. Because if we come if we come across an operation, we could just perform it and put that into the parts. The issue though is order of operations. Like we need to do all of the divisions first. Okay, I'm just gonna keep doing it in a very weird way. So now that we have parsed everything into an array, I'm gonna iterate again, find any division, and perform the division of the two numbers beside. Easy enough. That's literally all I have to do. So we're gonna go from parts.length. And basically first I want to do all of the divisions. We'll replace that operation with the result of the division, then we'll do the same thing for multiplication. Yeah, we can't use eval. We definitely can't use eval. So I think I'm on the right track here. I think again we'll call this token. This parts at I. And really we're searching for the division token. So if token is equal to $, oh wow, I've been live for way too long. If token is $, then basically we want to perform the division on the thing on the left hand side and the right hand side of the parts. So we'll say result is going to be parts at I minus 1 divided by parts at I plus 1. So if we log the result, well, we're not doing any division. Let's do a simple division. Should see 1. Cool. And now basically, we need to replace those 3 things in the array with this one thing. So what we'll say is parts at I minus 1 equals the result. And then we need to remove I and I plus 1 from the array. So we can say parts dot splice at I and parts dot splice at I plus 1. And then we reset I to be I minus 1. Keep on going. And at this point, let's log the parts. So did that work? That did not work. Yeah. So we just removed 2 things from the array. I minus 2. Alka is saying the mdn.i redirect is now using DuckDuckGo, so you no longer... Oh, that's good. That's pretty cool, too. They're using DuckDuckGo. And thanks for the follow, Molson82. Welcome. Okay, something weird is happening here, but... yeah, so if the token was a divisor, or is division, we perform the division on the things on both sides of it. Great. We then need to overwrite. Yeah, so if we think about this this scenario, I is 1 right here. We then overwrite it there. We remove I. Oh, and then we remove I plus 1. Why didn't that remove I plus 1? That's a good call, Postal Rat. Yeah, so basically, I want to, well, it would be, I think it'd be I minus 1, 3, and then result. I like that. But I still need to, reset I because we're in this for loop. And, oh, but the length of the array changes. I don't know, but you're right. That's a better way to do it, because what this will do is we say, what indice do you want to start at? And we actually want to start at I minus 1. We want to remove 3 things, and we want to replace it with result. Did Quokka break? Oh, thank you. That did it. Yeah, and then we reset. So if I don't reset I, wait, how does that still work? Because now I is on the opposite. Yeah, so I is like way beyond. But now we could do something tricky, like also divide that by 2. And now that gives us 0.5. So 2 divided by 2 is 1, divided by 2 is 0.5. Beautiful. Though, yeah, and I definitely need to reset I, because otherwise I has already been, I will try to use something that's not there. So I minus 1 needs to be there. Cool. So that's great. So we did the divisions. I think this is awesome. Here's what I'm going to do. I am going to turn this into a function that will just take in the operation and do the same thing. So function operate. And this will take in, let's say, it takes in a function. So yeah, we'll take in a function. And we basically need to do this code. Well, and it needs to take in parts too. So we'll take in, take in parts. And this function will do the business here. So we'll call the function on that. Like that. And then return the resulting. Well, we're technically modifying parts. This is not functional programming. we are modifying the parts array. I guess technically we could put it into a new array. That's fine. I'm tired. That's fine. So now what we could do is, instead of having this for loop here, I believe we can just say operate with parts and a little function that takes in A and B and does the division. Like so. So we'll do division, and then we'll do multiplication, and then we'll do addition, and then we'll do subtraction. And then we ultimately just return parts at 0. Cool. So does this work for multiplication? Nope. Oh, we need to pass in the operator thingy, not division. We need to pass in operator, like that. And so here we'll say parts and division. Well, actually, haha, got a better plan. This is great. This is not bad. I think this is a decent solution. Here's what we'll do. On our operations object, we'll store these little functions, and then we just iterate over the operations object and use the operations themselves. We'll change the order of the keys so that it does the things in the right order. So then we'll do addition, and then we'll do, multiplication, and then we'll do addition. It is time to hydrate. Thank you, Majestic iBot. And thank you for the follow, Dweepstify. Welcome. Yeah, we could definitely, if we iterate in reverse, then we don't have to reset I. That's a good call. Yeah, maybe we'll try that. I think, like, if I'm thinking through this correctly, this is gonna work. Let's take a quick stretch. Yeah, but let's see. Any Java people in the chat? I don't know. I'm definitely not Java. I mainly do JavaScript. Hello, Athal. Welcome. So here's what we can do. We'll say object.keys of operations dot for each operation. We want to call operate with parts the operation and operations at operation. Yeah, this should be 125. That's correct. I think this is the winner. Winner, winner, chicken dinner. And mainly because the order of the keys of this object are maintained. Cool. Yeah, we don't even need a result there. I really think this will do it. Let's see. That's 1. That's 1.1. That's 2. That's 0. That's 4. 3. 2.25. Negative 38.2. 20. Negative 10. 625. 1. 10. Ooh, we got this one wrong. Negative 9 instead of 9. 79 instead of 81. Oh, man. So if it results in NaN, we need to return a 400 bad request. That's easy enough. Is NaN? Parts at 0. Else parts at 0. Cool. So that should handle this. Let's copy this exactly and make sure we get the right text. Cool. So almost every scenario works except for this one. Let's see where we're going wrong. Oh. Let's think about this. Yeah, because if we do the division right here, that's going to result in 1. And then that's going to be 1 divided by 1, which is 1. And then it's going to be, yeah, so all of this results in 1. We multiply it all by 1. We add 2. That gives us 2. Minus 1 is a negative 1. Plus 9 is a negative 8. Minus 1 is a negative. This should be negative 9. Why do they have 9? I changed my shirt? No? Does it look different? I feel like these tests are wrong. Here's what I'll do. I'm gonna throw my code in the into Code Wars, and we'll see what happens. But I guess there's something that I'm not thinking about. Yeah, so 2 failed tests. That one is right. It should be negative 9. Okay, what have I gotten wrong? No, it should be 9. Sorry. Yeah. Okay, so that's a good sign. I mean, these 2 are the only ones I got wrong. So what are we doing wrong? look at it like this. Hello, Corey. Welcome. So, well, if we do, let's just work it out. So if we do 1,000 divided by 2.5, that gives us 400, right? So that should have been done first. That gives us 400. If we do 400 divided by 5, that gives us 80. Cool. So we keep iterating, and then we find one here. So we do 6 divided by 6, which gives us 1. Now we do addition. Oh, wait. Maybe I got the order wrong. Division, multiplication, subtraction, and then addition. I'm doing addition first. Is that the problem? Yep. Ha! Ha! So that's cool. I'm glad I figured that out. I'm really tired, and I'm tired of standing, so I need to go. But that did it. Thank you, Postal Rat. You were there with me the whole time. I appreciate you. Yeah, we did it. We'll do a final submission. At the same time, this is in the functional programming category, so let's make sure that we can we're doing this in a functional style. Because I don't think we are. I mean, we're not mutating external state. So operate is modifying the array. I mean, technically, we could just create a copy of the array and then modify the copy. That's still functional. I think I'm going to leave it. This was a tricky one. And we're going to forget that I ever tried to do it that way. Cool. Yeah. Let's go for final submission. Well, actually, any other thoughts? Postal Rat? Anyone else? Before I submit this thing. It's 2 p.m. in Hong Kong. You're coding like, I mean, here it's 22:54. I won't tell anyone. Yeah, I think there are functional programming aspects of it, like the fact that, yeah, push can take multiple arguments if you want to combine those lines. Let's see. Oh, push multiple things in. That's a good call. Cool. And hello, Parush, who says, I just landed to your page via Traversy Media. Welcome, welcome, welcome. Would love to learn from you. That's great. I got a ton of videos to learn from. I mentioned earlier, but this is going to be my last live stream for about a week or so. I'm taking a vacation, but I'll be back next week, probably first stream on Friday. Yeah, let's just see. Can I clean this up in any way? Not make it functional, but just make it nicer. So really, this could be a reduce. I'm never gonna give you up. Do a for of for the token. Yeah, why not? I don't think I need the indice, do I? Const token of route. Beautiful. Thank you, Eddie. Yeah, so we're doing a for of, but we also could do a reduce. I think I want to do a reduce instead. So basically, we're going to reduce the route to an array of parts. So here's what we'll do. We'll say const parts. This is going to be tricky because I'm pushing the value in at the end of the for loop. Okay. Never gonna give you up, never gonna let you down, never gonna run around or desert you. Doc is saying, could parsing each symbol be a split, map, and reduce? And then 4 of those nested? Probably. So what I'm doing here is iterating over the parts. Actually, I mean, this could also be a reduce because we're reducing this array into a smaller array, I think. Okay, let's clean it. Before I go, I've been streaming for close to 3 hours, but before I go, I want to make this nice. I'm feeling it in me. Like, I want to make this nice. Postal Rat is saying you could do a recursive function instead of the array manipulation, or not even create the array, but that would be big changes. Yeah. This is just the way my mind was working when I went into this, where essentially I parse it first to get the actual number values, and then once we have the number values, we can operate on them. And I mean, really, yeah, and because the other tricky thing is when they pass in numbers that have decimals in them. Yeah. Thanks for the sub, Tyler. Grax is asking, do I know Adam Wathan or Andre Mandaring? Nope. Never heard of him. Thanks for the follow, Deuce Too High. Welcome to the stream. Okay, let's make this a reduce. We're gonna make it a reduce. Parts equals route dot split. Hello, Conrad. Welcome. Dot reduce. Ultimately, we are going to get, and we'll destructure it, we get the parts themselves and the current number. And then we'll also get each individual token. And we're going to reduce this with an initial value where we have parts, which is an array, and we have a current number, which is a string. That's our initial values there. Now we need to do this business in here. Ultimately, we return an object with parts and current number. But we need special logic where, like, if this is the last iteration, we actually just return the parts array with that number inside of it. So we also get access to the index. I think that goes right there. And we'll say if I is equal to, we also get access to the tokens. Tokens.length -1. Then ultimately we want to return parts, but before that we can push into it. Oops. Let's take a break. That's a serious garden we've grown here tonight. It's almost hard to see all the plants. Yep, we've done it. So reduce is functional, right? So now that we have the parts, we then iterate over the parts to first do division, then multiplication, then subtraction, then addition. Cool. Tried to plant a tree and it missed. I need to refill my water though. Cool. So I kind of like that, using this reduce instead. To make this more functional, instead of pushing into the array, we could technically copy it every time. Let's do that, because why not? So we'll do this, and then here. Alka, ready for your one-line solution? Yeah, do you have one? Yeah. I was about to say, like, this would be very hard to do as a one-liner, but I mean, I would be extremely impressed if you did. So So that still works. Great. Yeah, so now we are no longer modifying that array. We technically are, I mean, this is a string. Strings, we're modifying, I don't know. I'm okay with that. And then let's see if we can clean this thing up. Yeah, I think we can turn this into a reduce. No, though, because we skip over the values. Let's try to turn this into a reduce. Return parts.reduce. Ultimately, yeah, we're getting access to the tokens and each individual token. Let's see. So if token equals the operator, and then I guess token starts off as a new array, which is a copy of all of the part of the oh, no. It just starts off as an empty array. And we'll return. Okay, let's think about this. If the token is an operator, then we find the result. I guess we'll pass in I. Because that's going to allow us to get the thing on both sides. Then we don't need to remove it. Ultimately, we return tokens with the value itself. So we're going to return all of the tokens with the current token on the end. But if we do this, we're going to return it with the result. And somehow we need to I guess replace it in the array. So really, we could say parts at I plus 1 equals the result. Because in the next iteration, when we do perform an operation, the reduce is going to be looking at the value that would have been at I plus 1, and we've now replaced it. Does this work? No, we've broken it horribly bad. Okay, we're not gonna do a reduce. I'm gonna stop streaming. It was a nice try, but I need to go. This is fun. It was fun though. Cool, and I actually solved it, which is cool. Also cool. Everything's cool. Thanks everyone for watching. Here, let me reset the drop board, and then we can get one last hurrah, one last a bunch of drops. How can I do that though? Fun for me because of the drop game. I don't want to drop the database because I want to keep all of the scores. Oh, I have an idea. Yeah. I think it's a great way to end the stream. We set the cooldown to 1 second, and also like we'll reset the board itself. Okay. Should I do it on the client? Yeah, should be able to do it on the client. Oh. No, we can keep the leaderboard. If I reset it, all of the all of the seedlings will disappear. So yeah, let's do it. Let's say the timeout is now going to be 1 second. We'll change it in the CSS first. So drops that have landed should disappear after 1 second. And similarly, that should disappear after 1 second. And then, there we go. All right, 1 second timeout. Hey, Anton, welcome. Oh, actually, need more precision on the score. Yeah, I could do like 4 decimal places. I'm down for that. We need to put on the thing that Doc made. CodePen. Full page view. What's up, Electrics? Welcome. I'm pretty much done streaming, so I'm letting everyone play the drop game with no timeout. So basically, you can just keep on dropping. Keep on dropping. Nice. Wait. Oh yeah, I was about to say why did that didn't count. Yeah, I'm ready for the Rickroll. We've had a great night. We've been streaming for 3 hours. We're gonna get Rickrolled soon, everyone. I want to play 2. All right, Morning Sage. It's fading in too. Cool. All right. Thanks for hanging out with us, Morning Sage. Have a good one. Beautiful. Yeah, that was great. Oh yeah, I was gonna drop on here too. Drop. I wonder if like YouTube detects the chat as like spam or bot accounts or something, because literally all of the messages are drop. Let's do chicken wing. Can't make the board at all. What someone mentioned earlier, we need to make it so that the droppers bounce off of each other. That'll be really nice. Ooh, deuce too high. That's a good drop. Yeah, 96.53. Great job, deuce too high. Great job. Great job. You did it. Not me, you did it. I'm gonna do a Doritos chip. That's the winner. Look at it. It's nice and slow, but perfect. Perfect. 100. That's gonna overshoot. If the chat could make it move, that would be awesome. Yeah, so if you got a slow enough drop, the main issue is a delay in chat. So like when a user sends a chat, it may not appear on my screen for like 2 or 3 seconds. But yeah, if you do like a left command, it can detect that you've already. Oh, Joe Mama. No, didn't make the board. Also, here's what I'm gonna do. I'm gonna make it. I'm gonna increase the number of scores that are on the leaderboard. Um, We're no stranger to love. Yeah, let's show 30 scores on the leaderboard. Look at that. That's awesome. uh, so there's a lot of names on there. We need some music. Well, the thing is, I don't want to get a copyright violation. We'll go back to that nice peaceful music where we're eventually rickrolled. Alka, if you're still watching, you only have a 52.7. That's your best score. There's an option in the header to disable a rickroll. Wait. Do I need to be on the code editing view? Volume up, volume down. It's on archive.org? Wait, is that song in the public domain? That's great. Or did you upload it to archive.org? Hmm. Oh well. Can I DM Alka? Oh, no, I can't. I'll send him a message on Discord. Oh, there you are. Look at the leaderboard, Alka. You only have a 52.7. That is that's shameful. Get some drops in, dude. For that. Actually, I could put the leaderboard on the left-hand side at this point. Is that a super chat? Rabbitworks. Thank you so much. $10 super chat from Rabbitworks. I'm just gonna leave this here. You rock, dude. Why am I not dropping? You're right. We're gonna drop a rabbit in honor of Rabbitworks. This is the winner. Watch this, Rabbitworks. We're about to huge score. Huge score. Look at this. Bounce off. Direct middle. No, it's not gonna. It's right in the corner. Anton is saying, do I know of any modern or relevant C# tutorials or courses for .NET Core? No. Alka, you're even lower on the leaderboard now. I think YouTuber Rick Astley has given up the copyright strikes for Rickrolling. It's time to hydrate. I wonder if Majestic Guy is even watching still, or he just has his hydrate bot going. Cool. Awesome. And thanks for making the hydrate bot. Yeah, definitely check Pluralsight. Is the dot? There's the Net Ninja. Yeah, there's the Net Ninja. I don't know if he's the .NET Ninja. Let's see. Yeah, because he's done a lot of stuff on Flutter and various things. There's someone on YouTube that does a lot of C#, but I'm not aware of it. Sorry about that. Yeah. Oh, there's an Alka. We're gonna keep this going until Alka is no longer on the leaderboard. Um, disabled Alka's cheats. Right, I'm gonna let these land. Oh, cheddar with the. Okay, I'm gonna. What? No, I'm refreshing. Alka was about to land. Yeah. Yeah, I'm sorry. It'll be fun because you always get such a high score in this game, and to think that with 30 scores displayed and you're not even on the leaderboard, you know, you know. Well, actually, I guess everyone. Oh, appreciate it, Rev but yeah, actually, I'm taking a vacation. I just took a week off of work. This is gonna be my last stream until like end of next week. So I am taking a break, and I appreciate you, man. Thanks for looking out. Thanks for thinking of me. Deuce Too High. Yeah, Deuce Too High is killing it tonight for sure. Two near misses. Beginner's luck. So well, Muhammad. The thing is, oh, we did it! We did it! Alka's not on the leaderboard anymore. somebody clip it. We have 30 scores on the leaderboard and Alka isn't there. This looks like a decent one, Alka, though. Maybe not. We're bumping people like crazy. Hello, Pranjal. Welcome. I'm just messing with him. The thing is, I think your app works, but if you ever watch him on InstaFluff's stream, um, he gets insanely good scores. I swear I don't have any custom code that's making the Alka ones miss the target. Just barely. Um, cool. I plan to just stay at home and do nothing for my vacation. The main thing is I don't want to think about anything. I'm gonna talk to my mods, but I'm gonna stay off of Discord. I'm just gonna unplug, totally unplug. There we go. That's nice. This is insane, Alka. Lies. Like I am. Thank you, Doc. I am so like Alka just like keep. Oh, this. Nope. Just overshot it. That's a great job, Carolinda. Oh, there we go. Alka on the board with a 92.57. Beat that. Great job, Alka. All right. Yeah, that was great. Is anyone streaming that we can raid? Let's see. Let's look in the science and technology category. Moon craters. Let's find someone with like no viewers. That's writing code. Someone with no viewers that's writing code. This person just has testing. Walk the web. Oh, it's a rerun. Don't want that. Live coding episode 50. Let's see what they're working on. Rabbit works?
There's no description, I think.
What's he working on?
Namespace. Get my namespace.
Oh, this is like a Office extension or something like that? Interesting. See you later, Mattia. Oh wait, Rabbit, are you going live right now, Rabbitworks? we will raid you if you are. Carolinda says, thank you for streaming. Have a great vacation. You're awesome. Everybody here is awesome. Have a great night. See you later. Thanks for hanging out. And are you on the, yeah, let's see. Are you on the leaderboard? Yeah, Carolinda's got a 93.53 on the leaderboard. Cool. Yeah, and if you're watching on YouTube, come over to Twitch if you'd like to watch more live coding. We're gonna raid someone. Not that. Cool. Yeah, let's find someone. Building Linux from scratch. Grumpy game development. I want to find someone doing web development, though. Web. Oh, Codephobia. Let's raid Codephobia. Is he doing TypeScript? No, it's just JS doc. Cool. All right, we're going to raid Codephobia. Cool. Oh, wait. Next time. Wait. Oh, I mean, are you going live on Twitch? Is this a thing? Maybe not. The higher you're on the leaderboard, the more times you run the drop command. That's probably true. Oh, no worries, Sharpie360. Okay. Thanks, everyone, for hanging out with me. This was super fun. I'm taking a vacation! So I'll be back probably next Friday. So, like, I mean, I used to go without streaming for, like, months at a time. But I've been streaming a ton lately. So, yeah, I'm going to go on vacation. Thank you, everyone, for hanging out. Thanks for being a part of this little coding garden thing that we got here. And be sure to help me raid Codephobia. Oh yeah, let's get our raid message ready. We're gonna raid hard, all right? Everybody that's in the chat right now, I need you to send this raid message. I need you to. I absolutely need you to. Alrighty, everyone, wherever you are in the world, have a wonderful morning, afternoon, evening, or night. And until next time, here's this.